In thermochemistry, we often talk about specific heat capacities. So what is a specific heat capacity? It is the energy needed to raise the temperature of 1 gram of a pure substance by 1 Kelvin. We can also write that this way. Cs, the specific heat capacity, is the energy needed in joules to raise the temperature of 1 gram of a substance by 1 Kelvin. And we can also write that a little bit shorter. So it'll be joules over gram Kelvin. And please note that joules over gram Kelvin, that is the unit for the specific heat capacity. We could also write a more general formula for this. So we could say Cs, the specific heat capacity, equals energy as heat, Q, over a mass in grams times a temperature difference, so delta T. Now please remember that delta T stands for temperature final minus temperature initial. We could also rearrange this equation to solve for Q. So in that case, Q would equal Cs, the specific heat capacity, times the mass in grams, times delta T, the temperature difference. And this may appear a little bit abstract, so let's do a quick example. So let's say I want to boil some water for some pasta. So here I have some water in a pot, and let's say I have 3 liters. And the initial temperature might be 293 Kelvin, and I want to bring it up to boil, so 373 Kelvin. The question might be, what is the heat requirement for this process? What is the energy requirement for this process? Well, over on the left we have our formula, so Q equals Cs times mass times delta T. Now the Cs value we can look up in a table, and we are looking up the specific heat capacity for liquid water, which is 4.18. Please note that the specific heat capacity will depend on the state of your substance. So whether it's solid, liquid, or gas, you will get a different value. So for water, it is 4.1, so 4.18 joules per gram Kelvin. And the mass, well, I said I had 3 liters of water. If we assume the density of water to be 1 gram per cubic centimeter, then 3 liters would be 3,000 grams. And delta T, well, temperature final is 373. So this is TF, and this is TI. So 373 minus 293 is 80 Kelvin. And we can see that some units will cancel. So this this Kelvin will go, and this Kelvin will go. This gram and this gram will go, which means we would be left with joules only, and that is fantastic because we are solving for heat, we are solving for energy. So our number should be in joules. So all that is left is to use the values. So 4.18, the specific heat capacity of liquid water, times the mass, which is 3,000 in this case, times the temperature difference, which is 80. And I get 1,003,200 joules. And we can shorten that to 1,003 kilojoules. And that would be the answer.